So Vincent and I are going to be talking about two projects. The first is called Arturo-STAC-API. The second is called Titiler. Both of them are FastAPI applications. They're kind of designed to work well with one another, and they're part of this kind of larger goal of creating applications that are easier to deploy alongside each other. So if you have like a use case where you need to deploy like a Stack API and a COG tiler next to each other, trying to make that a little easier to do, because right now the tooling just doesn't exist to do that. So I'm going to start by explaining kind of the Stack side of things, and then that'll last, I think, 15 minutes, and then I'm going to pass it off to Vincent to explain more of the COG side of things. Sweet, so let's get into it. So this is the API. This is Arturo's official like Stack API implementation. At first, it was just kind of a GitHub repo that had a Docker file that contained an application that someone could come in and use and deploy. At the last Stack software sprint a couple weeks ago, we put in a lot of effort to refactor most of the library from a repo which ships an app to a Python library which actually lets you create one. So let's kind of dive into what that looks like. So I just have a Python file here right now. It's just sitting in the root directory of this repo because it's not on PyPy just yet. It will be on PyPy in a couple days. But so the way this kind of works is we have this API settings class. So this API settings, it's all of this uses Pydantic under the hood. So it pulls in a bunch of information about these come from the environment. It's coming from this .env file. It also contains some settings like what extensions you have enabled, what add-ons you have enabled, things like that. What default includes are going to be returned by the API. So the first thing we do is we create the settings object, and then we can actually import the function that is basically a factory, which creates an application. So we can create the app, we pass our settings in, and now we can serve this with really anything that, whatever your favorite server is. Personally, I use Unicorn for local development. So we can go test app. Now we have a server running. So I'm going to be switching between the IDE and the browser. So just bear with me. Let's go here. Cool, so we have a Stack API now. There shouldn't be any data. There is data in here. That's unfortunate. That shouldn't be there. I'm just going to delete that real quick. Everyone close your eyes. So here's the actual PostGIS database that I'm just running locally. So I'm going to delete all these items because this was supposed to be part of my demo. But when I was practicing, I forgot to clean up after myself. So we're going to delete that. Cool. So now we have what I hope is an empty Stack API. Cool. So there's no collections. There's no items in this at all. One of the cool parts I will point out about FastAPI is there's an automatically generated FastAPI docs. So if we look in here, the app by default just comes with the core Stack endpoints. This includes the basic get search kind of RESTful endpoints here. It also has the search endpoint for cross-collection searches. And then we can go down here and we can actually look at these. So if we looked at an item, for example, it has a type, a geometry, and properties, etc. The cool part about this is that it's actually it's dynamically generated from the validator that you use to validate the API input. So for example, if I go back to our code and I pull up the actual definition of that item model, which is in here, if I add my own field, make it a string, and if we refresh this, then you're going to see the foo thing added here. So the cool part about this is the documentation kind of updates as you update the API. The whole idea of this project is to allow people to kind of configure their own APIs and potentially add their own behavior onto Stack to accommodate their use case. And so the documentation will update as you do make changes like that, which is a nice feature. Let's get rid of that because that'll cause problems in the future. So having a normal a Stack API with nothing in it isn't super helpful. What we can do, though, is we can enable one of the Stack API extensions called the transaction extension. So if we let the app refresh, it's very helpfully telling me that I have a typo in here. Cool, the app is back up. If we go to the docs page, you'll see this bunch of new routes have been added on, a bunch of for creation and deletion of stack items. So this is the basic way that extensions are added into the API. Right now, as you saw in this little error message, it supports these API extensions here, which I believe is everything except the version extension. Cool. So now that we have the transactions extension, let's actually ingest some data. I have this script that comes with the repo. I'm basically have an item collection that's saved on S3, and I'm just going to use the requests library to move that data into the API. So we'll run this script. Should see a lot of post 200s. That looks good. It finished. Now we can go back here and we'll have this collection. We can go in and look at the items in the collection. All this is super standard Stack. We could do a /search, look for items in the Joplin collection, and get them back. Cool, maybe we want to add another API extension. Maybe we want to add the context extension. I'm a big fan of this extension. What this one does is it adds on a context object to search responses, which we'll see in just a sec. So you can see there's this context object now that'll return the number of items actually returned by the query. So if we bump this to, oops. I hope this updates. It does update. And then the total number of ones that are matched by this query. I guess this should be 3 as well. Anyways. The second thing that we're supporting, and this is kind of a newer feature, so it's a little still in development, but it's something that we're going to continue to develop and add more functionality to in the future, is add-ons. So often with Stack, you want to extend it, you want to have it work better with a certain data format. You want to add your own functionality that goes beyond the core kind of focus of Stack, which is search and discoverability. And so we can do the Tiles add-on. The Tiles add-on is specifically designed to work with a Stack catalog that happens to index Cloud Optimized GeoTiffs. So we can go back here. We go back and look at the documentation again. We can see a bunch of endpoints have been added on. We've added on this OGC Tiles endpoint. This just extends the item ID URI with a /Tiles resource. We also have all these Titiler routes, which there's a bunch of stuff for tile map servers. There's to get some metadata, get info, get bounds of an image. One of the things that I really like is there's this WMTS capabilities, which is cool. Nonetheless, if we go back to pull out one of our items, let's take the second one. And you also see there's a tiles endpoint here now. If we just send a request to this, it's going to pull up a little viewer. This viewer is shipped with Titiler. And as you can see very slowly over my horrible internet, we're going to slowly kind of see what this stack item actually looks like. I don't want to spend too much time playing around with the viewer right now, but it is really cool. There's a lot of cool stuff you can do. Like if your catalog often has one band per asset, you can go in and you can play around with the band combinations. You can do color formulas. You can do a lot of cool stuff with this viewer. Oops. Yep, and that's about it. One last thing is under the hood. This is using the OGC API tiles to facilitate all of this map rendering. And so if we switch our application, our request header to JSON, and just send this, oops, not that request again. We have to go back to the tiles request. Do this one. Once the app reloads. This is what's happening under the hood. This is just an OGC Tileset resource, which should look very familiar to a lot of Stack resources. It's a JSON blob with some metadata about it, a bunch of links, and a title. Here, the links are just pointing to the Titiler endpoints that were added when we enabled that add-on. So for example, we could get like a WMTS capabilities document for this stack item. I think this is super cool because you could copy and paste this URL into QGIS if you wanted to, or anything that can read a WMTS capabilities document, and then you would actually see that image viewed through the stack item. There are other nice specifications like tile.json. You can get the tile.json from it. It has the TMS URL, has more bounds and zoom information. Yeah, so that's the first add-on that we've added. The next two that we're looking to add on is, the next one is going to be Mosaics. This is going to be essentially the same implementation of COG plus stack, but it's going to be when you have multiple stack items instead of a single one. So this will let you visualize the output of a search request, for example, where you could actually on the fly render the map tiles together, or sorry, mosaic the images together and render map tiles from that kind of on the fly mosaic. It uses Mosaic JSON, which is kind of like a cloud optimized VRT for those who are familiar. And the next one that I want to add is dynamic collections. Dynamic collections is just implementation of a SQL materialized view, where you can save the output of, say, a search query into its own collection, and then query that collection just like you could any of the other collections, except this dynamic collection, it's not saved anywhere as a table in the database, it's just a view that's being stored and updated. That's everything I have. I'm going to pass it off to Vincent, who's going to talk more about Titiler, which is the tile server that was used for this. He's going to dive into more of the functionality and cool stuff that you can do with it.
Thanks, Jeff. Awesome.
Yeah. Do I need to stop sharing my screen? Yeah, I do.
Yeah.
There you go.
Let's try that. All right, you should be able to see my screen now. So as Jeff mentioned, well, I'm going to talk about Titiler. Titiler is a new tile server, dynamic tile server that we created at development seed. And so when I say it's dynamic, it's because it's based on Cloud Optimized GeoTiff, meaning that the tile server will read the raw data stored in your Cloud Optimized GeoTiff and try to create map tiles to display on your client application dynamically. So reading the raw data, do whatever you want, like applying color maps, applying color rescaling, for example, and create the PNG, the output PNG to display on your map tile. So instead of storing PNG or JPEG on your S3 bucket, we store the COGs, and then we use Titiler to create the tiles on the fly, and also to perform like analysis or custom processing before creating the visual product that you want to display on your map. So Titiler, so like for the past 2 years, I've been working on the field of dynamic tilings from Cloud Optimized GeoTiff. And so we did like a bunch of other projects, but Titiler aims to be the one that will succeed, like that we are only going to work on because the past projects were built to work only with AWS Lambda, which was nice because AWS Lambda is a great infrastructure to build a dynamic tile server because it can scale quickly and it's pretty fast. But then we were blocked because with the past project we were only using AWS Lambda. So we decided to build a new one that could work on any kind of infrastructure, like could work on ECS-based Docker images, for example, or on EKS if you use Kubernetes. and or locally on your own machine if you want. So Titiler started with that just as a project trying to use the latest kind of framework that exists and the good also all great Python modules that exist right now. And so, and we tried also to add more features than just Cloud Optimized GeoTiff support. So Titiler has support for Cloud Optimized GeoTiff for stack items and also for Mosaic JSONs natively. And we also support like multi tile matrix sets. So if you want to work with other projections than Web Mercator, you can also use different tile matrix sets that are provided by a module called Mercantile. And so yeah, so it's a way more complex, complete application than the one we used to build before. And so, as I said, we try to use the latest framework, Python framework available, and we decided to go with FastAPI because it's a really nice Python framework to build a simple application, an API. And so, if you have never worked with FastAPI, I highly encourage you to check out FastAPI, and it's absolutely great. So as Jeff mentioned, Titiler started as an application, he mentioned that for his application, but it's definitely the same for Titiler. We started building Titiler as a full application that you could just git clone and deploy on your own infrastructure. Then we moved to something more closer to a Python module. You can just, if you want to try Titiler, you can just do pip install Titiler. You can add optional install packages to be able to run it locally. So if you do pip install Titiler bracket server, it will install the UV corn web server on your machine, and you can just start Titiler. So I'm going to do it live, and so we'll see how it looks. So I just did UV-corn Titiler and the main application shipped with Titiler. So there is nothing on the base page, but Titiler FastAPI builds the docs for every route that we have, every endpoint that we have. And so, as I said before, the Titiler API comes from support for Cloud Optimized GeoTiff, Stack, Mosaic JSONs, and different tile matrix sets. So for each endpoint, we have different documentation, and you have documentation for each routes within the endpoints. So which is really nice because having the documentation could help for the users that don't know anything about the endpoints. You just go on /docs and you have the documentation endpoint, and so it's a really great features from FastAPI. So yeah, let's do some demo. So let's start with COGs. So thanks to Digital Globe, they now provide like a lot of Cloud Optimized GeoTiff at high resolution for the disaster program. And so what we can do is just go for some events and get some data. So let's take the Mauritius spill oil, and so I'm going to check some image. I know this one look great. And so I'm going to use the viewer that is shipped within Titiler. And because I know the URL, it's COG viewer. I enter the URL. And so if I check what's going on there, so basically it's a bit slow because my connection is quite slow right now. But Titiler is going to fetch some metadata about the data and then create the tiles dynamically. So, and we can like pan and zoom, and it should be pretty simple. So the viewer that we are seeing right now, it's like the default viewer shipped with Titiler. So, so you don't have to build your front end if you just want to try Titiler. There is a front end shipped, a web page shipped with Titiler. So again, you can pan and zoom, you can interact with the data, you can change the bin combination if you want. And this is just enabled because it's dynamically, we create the tiles from the COG image on the fly. So that's great. So that's the basic support for Cloud Optimized GeoTiff. Let's try with Stack. So I've got another one. I've got a stack item that I found on stackindex.org. And let's go to, so it will be pretty much as what Jeff showed earlier. So you go on StackViewer, you post the stack items. And what's going on there? It's the API first will get the items, so the JSON document, and see what assets are available, which Titiler can read, because Titiler was built for Cloud Optimized GeoTiff, so it expects items to be the assets within the items. What did I do? StackViewer. Oh, sorry. Let's go. Okay, stack. Okay, that should work now. So Titiler will expect the assets within the items to be Cloud Optimized GeoTiff. And so if we look at the assets there are 5 assets that are Cloud Optimized GeoTiff within the items. And so you can select whatever items you want. And as Jeff showed, you can also merge the assets and do bin combination on the assets combination on the fly, and display the results of the items. So you just need to do some color scaling to display the assets. But yeah, that's the basics support for Stack. So Titiler will fetch the items, see what assets there is in the items, and then let you do asset combination if you want. If you store different bands as different assets within the items, or if you just have one asset with multiple bands, you could also just see what's going on in your assets, in your items. Yeah, so what we did with Titiler was basically try to help the user deploy their own tiler, but also help the users to create custom tilers, just not made only for COGs or for one file store somewhere on the internet. And so we try to make the customization as easy as possible. And so wait, I'm going just to, yeah, customization. Okay. So that's where I wanted to talk about the Tileset Factories. And Tileset Factories within Titiler are just Python data class that will create a FastAPI routers with all default routes, to get the tiles, get the metadata, get the info from different files, from Stack or from Cloud Optimized GeoTiff. And so if you want to build your own tiler with only COG, Cloud Optimized support, this is the only few lines that you have to write. And because I'm creating a Tileset factory, that support only COGs, and I'm assigning some prefix on the routes, but that's pretty much the only thing you have to write, to deploy, to create your own dynamic tiler using Titiler. And if you want like to create more complex tilers, like this one, if you can read the screen, I'm going to this like 100 lines, yeah, is creating a custom dynamic tiler for all, for some data sets stored on AWS, like Landsat, Sentinel-2, or the Sentinel-2 data store as Cloud Optimized GeoTiff, using a plugin called GeoTiler PDS that we just released. And so the way Titiler is built on GeoTiler readers, and so those as custom readers. And so basically, what we can do is just we create a custom path handlers. So the path handler usually gets that's the one analyzing the URL that you pass to the endpoints. And so this is the only bits that this is the most important bits. Like if I pass a URL or a string starting with Landsat, it will give to Titiler the Landsat 8 reader. And so I think I had the page somewhere. Yeah, it's there. So this is the application. This is the documentation page created from the custom PDS tiler. And so if I pass Landsat plus a Landsat IDs, oh, there is a small space there. Landsat plus the Landsat IDs, and I execute, it will, oh, not found, oh yeah, because it's already running somewhere else, sorry. To kill some processes, I guess. I don't know what's going on. Okay, it's there. It's usually work really fine. I don't know why. Ah, no, I started the wrong one again. Okay, sorry about that. Okay, it's there. So I'm going to start the PDS tiler. Yeah, we are. And so now if I pass Landsat plus the scene ID, it should work fine, right? It's starting. And okay, this is pretty slow. I'm sorry. Okay, go. No? Oh yeah, so I don't know what's going on. Maybe too many things running on my computer right now. But yeah, so we worked with Jeff and also Kyle Byron to write the documentation for Titiler. So if you go on GitHub, so everything is open source again. I didn't say that at the beginning, but everything is open source and freely available on GitHub. So if you go on Titiler, there is a documentation web page, and we try to include as much information on this web page. And so you can find examples about like running more complex COG analysis using Titiler's endpoints or stack or even the Mosaic JSONs. And so there are also notebooks available for you to try. Or it's on docs, examples, and like there's the example I showed, like using the digital globe data is on this this notebook, for example. So it's not working yet. I don't know what's going on. Anyway, okay, I think I'm done. I don't know how we are on timing, but it's pretty much a good intro for Titiler, I hope. And so this is just as an intro. So this is working on, so we built Titiler working with raster data. We also built like TVT-Tiler, TMVT, which is like the same FastAPI based Python modules working with Postgres to create like the vector tile dynamically. No. Yeah, just needed to talk about that. All right.
I think we've got 8 minutes to the next session, so if there's any questions. I have a question, which is, what are you guys planning next? What do you hope to develop in the future?
My big thing is mosaics. So it's cool to be able to, and I had a working implementation of this a while ago that I hated so much that I threw out. And with Titiler kind of changed to work to be built how it is built, is that it is possible to do it in a way that's better. But yeah, being able to look at a single image, being able to look at a single item at a time is cool. It's definitely, I think, more valuable to have that mosaic capability where you can take like multiple stack items and view them together dynamically. So that's the next big thing for me, is say you can drop a bounding box into like a stack search endpoint and then actually see the image tiles that come back from that search.
Yeah, that'd be pretty awesome. So just do it completely on the fly, whichever API or whatever search you select, you would have the mosaic.
Mm-hmm. Yeah, and it's really as simple as just adding that /tiles endpoint like everywhere. Like add it on the end of collection, add it on the end of item ID, add it on the end, add it as a rel type on the item collection returned by search, and then everywhere there will be a tiles asset, whether it's one image or multiple images. You would, if you looked at those tiles, if you looked at that tile layer that was created, you would see all the imagery that's there.
Yeah.
So I see some question on the. Yeah. So there is a question about async, and yes, so there is the AI COG created by Jeff, that we'll try to implement as a reader, as a supported reader in Titiler. And we also discovered that GDAL has some C++ API working for working with async. And so, but right now, yeah, it's not the Titiler implementation as it is right now just is not async at all.
Yeah, goal to get there though. Yeah, that's why I wrote that Python library, is because if you think about it, actually my boss at Arturo, when I was explaining COGs to him and how we have to use this software called GDAL to query them, he was like, wait, that makes no sense. This is just reading bytes from a file. Like, why isn't this asynchronous? I'm like, but it's hard, man. Like, there's compressions and data formats and like all this nuance that GDAL abstracts away, and most people are just okay with that. But this is really like reading tiles from COGs it really is an embarrassingly horizontal process that async is perfect for. So I would love to use AI CoGeo in the future. It's just not mature enough yet because, again, it's trying to like make up how many years of GDAL development when it comes to dealing with compressions and data formats. But the goal is eventually to have like a purely asynchronous tile server.
There is a question from Matt about an old project like called COG Tiler. And so, yeah, basically we are going to depreciate COG Tiler in favor of Titiler because it's just a more complete implementation, and it's the way it's written, it's way better than COG Tiler that is based on one of my old projects to only work with AWS Lambda. And so Titiler is definitely the way forward for dynamic Tiler based tile server. I'm just going, how many minutes we have left? 4 minutes. I'm going to demo the Mosaics part because yeah, we have time left. So this is just a simple notebooks that is reference in the document, the Titiler documentation. So what I'm going to do, I'm going to use the digital graph open data to create mosaics. And so, as I just mentioned, this is based on Mosaics JSON specification that we created at development seed, which is like a VRT. We combine different files and we just say the files are in this place on the earth. And that's basically, if you want to learn more about Mosaic JSON, you can check Mosaics specification on development at GitHub. So I'm going to scrap the Digital Lab webpage to get all the files available for the latest California Colorado fires. And so there are 54 GeoTiffs. I'm going to filter by post and pre-event. And then I'm going to use REST-Stereo to get the bounds of the data and just to create a GeoJSON with all the data available. So we see that's only for the post events. So we see that we have different cluster of data. And so this is also going to answer another question we had about authentication. So right now, Titiler doesn't have any authentication process, but the API behind API.cogio.xyz built on top of Titiler has some auth features that I just did like yesterday night. So basically, I'm going to create a token. So because I don't want everyone to be able to upload a mosaic, for example. So I'm creating a token, but right now everyone can create a token, but that will change in near future. And I'm going to pass the files that I want to be in the mosaics to the Titiler mosaic JSON endpoint. And so this is going to take a couple of seconds, because Titiler has to get all the files and to create the mosaic document. And then I can just give the mosaic. So this create endpoint created a layer called anonymous. So that's the layer I just created. And then I can use Titiler to read the data, to read the mosaic JSONs and to display the data. So where are the clusters? Oh yes, it's there. So if I zoom in, we should start seeing some data appearing. And so yeah, it's quite slow because it's not really optimized right now, but you see the mosaics of Cloud Optimized GeoTiff. So yeah, so it was pretty fast to create anyway. So yeah, basic, and again, so the auth part is just on top of other Titiler features. So basically, if you create your own Titiler, you could just have access to the mosaic JSON part quite easily.
Yeah, so now imagine having that built into a stack catalog where you can view all the NIP imagery for a city or whatever, or yeah, cool stuff.
Thanks a lot, Vincent and Jeff. Chris said he had to drop off, so if it's good with y'all, I'm going to take over.
Yeah, of course.
Thanks.
Cool. Thanks again for the presentation. I really like seeing the Titiler progress. It's really cool stuff.